Welcome to this film on how to use a compass and a map. We'll start by looking at the compass and we'll get to the map later. So let's put that down there. The compass. This is a pretty standard compass. Many of them look somewhat like this. This one happens to have a bottom plate here with a magnifying glass here. The magnifying glass is very useful for reading map symbols, especially if, like me, your eyesight isn't always the best. It also has scale bars along it and a simple rule here for measuring distances on the map. This base plate feature, not all compasses have them, even though it is fairly standard to have something like this. Not all of them will have them, but it is a reasonably common feature. But these are secondary features of the compass. The main feature, of course, is this magnetic needle here. And that is kind of what defines the compass. And it reacts to the dominant magnetic field in an area, which hopefully is the Earth's magnetic field. It could be that the magnetic field locally where you happen to be standing is influenced by, say, a ferromagnetic body in the ground, electricity pylons, some other thing on you, another compass or a magnet that you have, so you have to be careful of that. But otherwise, in other situations, generally speaking, the compass needle, this thing that rotates there, will react to the Earth's magnetic field and point towards north. The red part of that points towards north. The other main feature of this compass is the bevel and housing. So this is the housing for the compass needle, and we can rotate that freely, independently of the magnetic needle and independently of the bottom plate. Around the edge of the housing we have this bevel where we have the degrees of the compass marked out. And we can see that we have north going around that way around to south and then back to north again, 0 to 360 degrees in a standard compass. How do we use this? There are two situations in which we will use this. One is in the field, when we want to take a bearing towards an object from where we stand. But the first use, which I will show shortly, is with a map, to read a bearing from a map. So this is a map. There's nothing special about this map, it just happens to be the map that covers the area in which I am now. We can see that it has lots of fairly standard features. The lines we can recognize as roads. We have fields and forests marked out here. The exact symbology used will vary from map series to map series in whichever country you're in, but they are all fairly similar in most respects. One thing that they should have is these lines that perhaps you can't quite see. I'll try to come a little closer. These thin black lines running north, south, east, west. And we're most interested in these lines running north and south. These are indicate the maps north in here, which approximately matches the north shown on the compass. It's not exactly the same, but they are approximately the same, good enough for our purposes here. So how do we read a bearing on a map? This is the first objective we have, is to read a bearing on a map so that we can work out how we take ourselves from one point to another. And to illustrate this, we will take a bearing from the point where I'm standing now, which is there, and we will go to that point over there. And to do this, we will use firstly the bottom plate, this bottom plate here, and we will line the edge of the bottom plate between the 2 points, our start point and our finish point. And we will line it up so that we start from down here and go that way, so following that arrow up there. So if we set the bottom plate, the edge of the bottom plate onto the map, and let's see if I can get this right, on our start point, so the edge just lines up with our start point and then goes to our finish point there. So we line them up like that. There's our start point, there's our finish point. We line them up, and there. That's the bottom plate is now aligned with our desired direction, but we still don't have a bearing. So the next job to do, let's see if I can move that There we go. Let's get that out of the way, just to not confuse things. The magnetic needle was in the way. We're not interested in the magnetic needle right now. We're working with the map. The magnetic needle shows us reality, as it were, and maps are not reality. So let's just focus on the housing for the needle. And we can rotate that until the black lines in that housing are aligned with the black lines in the map. Now it just so happens that the magnetic needle got pulled along with the housing. So it's perhaps not 100% illustrative of what I mean. But we're looking, ignoring that red needle, the red and white needle that is magnetic, and just looking at the bottom plate there, those lines, and they should line up with the grid lines in the map. And that would appear to be the case. So now we have our direction indicated by this bottom plate and the map north indicated by the housing here. Nothing to do with the magnetic needle. A secondary point on that with the magnetic needle rotating with the compass, this is something to be wary of when holding and using a compass. Hold it flat so that the needle is free to rotate. Now we have a bearing read off on this map. But what is the bearing? To read off the bearing, we simply lift up the compass and we can read off the bearing up here. This reading up here tells us our bearing, and that happens to be, let me see, so that's 110, 12, 14, so I'd say about 116 up there, 116, just a little bit shy of 120. That's our compass bearing. That's what we want to follow when we're in the field, when we're going to walk to the next point. How far do we have to walk between these 2 points? And as I've shown before, the bottom plate on the compass actually has a number of scales and a little rule there. These can help us to read off the distance. First of all, we need to know what the map scale is, and on this map we can see indicated up there that it's 1 to 25,000. 1 to 25,000 means that we have 25,000 millimeters in reality are equivalent to 1 millimeter on the map, or 1 millimeter on the map is equivalent to 25,000 millimeters in reality. 25,000 millimeters, well, divide that by 1,000, that gets us 25 meters. So 1 millimeter on the map is 25 meters. We could just measure with a normal ruler, but luckily this compass happens to have 1 to 25,000 scale marked out here. So we can just read directly from here. How do we do that? We take our map again and we hold the 0 on this scale bar. I can get in there to show you. Hold the 0 of the scale bar. We don't need to do any rotating. Hold the 0 on our start point and then read off over where our finish point is. And if we look there, that would appear to be just over 1 kilometer. 1.1 kilometers. That's how far I have to walk to get between the starting point where we are now to our finish point. So now we come to the point where we want to use our bearing to get from one point to another. And the way we do that is to rotate the entire compass. Not the bevel, not the housing for the compass needle, but the whole thing. We rotate them until the 2 red arrows match up. The red arrow of the base plate and the red arrow of the magnetic needle. And then when they match up, this then points in the direction we want to travel. The compass is now pointing in that direction, telling us which way we want to travel. Now that can be very difficult for you guys to read there, because the camera is looking straight forward, so it's quite difficult to see down onto this bottom plate. To get around that problem, there's another type of compass, works in pretty much the same way. Everything is exactly the same, except for it has one extra feature. That extra feature is a mirror. You can see this mirror here. And this mirror has inside it a sighting hole. Down the bottom there, I think you can see that now. So that we can use that to sight where we want to go. The mirror is not for doing your makeup, it's for looking at the housing and the needle to see that they match. So now I'm going to see if I can get this on camera. So what we do is we set our bearing, we rotate this until we have our bearing, which we said was 100 116, I believe, somewhere around there. So we've now set the bearing up there. We rotate that down and we want our needle to match. And if we look, when it's pointing there, you can't see that, so what I'll do is I'll try and rotate this very carefully so that you can actually see it. And if we look there, hopefully, if that's working properly, you should now see, as we rotate, they match up. And then we can look through this hole here at the back and say, right, we want to go in that direction. Similarly, we can use this for measuring an object. If we want to make a map ourselves, if we're mapping objects, we can just sight through here to an object and read off the bearing. We rotate this until we get the right bearing, whichever way we want to do it. So now we have our direction. We know we want to go in that direction over there, and we want to go 1.1 kilometers. So throughout this, we're going to check our bearing on our way to the next point, regular intervals, looking for objects in the distance that we can aim for. So we look at the compass and we try and align the needle with the red arrow in the bottom of the compass. Hopefully you can see that, that's in focus. And then we look through either our sighting, or we can look over the top of the mirror for something in the distance and aim for that. And then we'll just keep redoing this until we get to our destination. So we're going to head off in that direction. So now we've made it. With the help of a compass, we've arrived at our destination. There's not a great deal to see here, but here we are anyway.